Hello everyone, my name is Ashish Agarwal and I am currently working as a senior software engineer at Uber. Today we are going to talk about consistent hashing, which is one of the most important concepts of system design. Let's say we have to store a lot of data, for example 4 TB of data, but our servers can only store 1 TB data. Okay, so how many servers would we need? We need 4 servers because we need to store 4 TB data and we have only 1 TB servers, right? So we will need 4 servers. So the problem is that we don't know which user's data will be present in which instance. So we need to determine that and we need some kind of algorithm for it, right? So let's talk about hashing and see how hashing can solve it. Okay, so first let's talk about what is hashing. So hashing is nothing but a function. So it's a function which takes certain parameters and you pass the same parameters to the same function every time, you get the same output. For example, if I say f of hello world is a string, I can pass anything. Let's say it gives me 152. So every time I pass hello world to this particular function, it would return me 152 as output. Okay, so we can do something like this. Let's say we have 4 servers. It's S0, S1, S2 and S3. Okay, so and we have millions of users. So now what we do, we compute the hash value for each of the users. Okay, so then let's say we, for the same function, we compute the hash value for user 1 and we get some data. Let's say 152 for example. And then since we have 4 servers, we'll do a modulo 4. So now this would give me 0. So this means that the data for user 1 would reside in server 0. Okay, now let's take another example. Like for example, if I do user 2 and let's say it gives me 7 as output, the hash value. I do a modulo 4 and over here I get 3. So now we can say that the data for user 2 will reside in server 3. Okay, why we are doing modulo 4? Because we have 4 servers, so we need to determine like whether it is 0, 1, 2, 3. Okay, now we want to read the data from a given server. We can use the same hash value and we can also use the same hash value when it comes to writing the data. So whenever we are doing an insert or an update, we just follow the same mechanism and determine which server the data is stored in. And when we don't want to read the data from the server, we can again use the same hashing algorithm to determine which instance has the data. Okay, now let's take an example. Let's say we have 4 hash values. Okay, the 4 hash values come out to be, for example, 152, 7, 81 and 18. I'm just taking randomly 4 users and then doing an hashing. So now 152 modulo 4 would give me 0. That means this user's data would reside in server 0. 7 modulo 4 would give me 3. That means this user's data would reside in server 3. Then 81 modulo 4 would give me 1. That means this user's data would reside in server 1. Okay, and 18 modulo 4 will give me 2. That means this user's data will reside in server 2. Okay, so now we have 4 users and we have kind of distributed the data in 4 different servers. And you can assume that the hashing function would just try to uniformly distribute the hash values so that each of the servers kind of gets a similar load. Okay, now the problem arises because we cannot say that 4 TB is the only limit, right? Like the data size can increase to 5 TB, 6 TB, anything, right? And then the use case would be to add new servers. Or let's say if you want to decrease the number of servers because let's say there are no more users in our system or there's very less data to store. Okay, at that point we can decrease the number of servers. Now let's see, with the same set of users, if we increase the number of servers to 5. Now let's say if we had 5 servers, how would the data that is stored in the servers change? So there needs to be some kind of rebalancing, right? I cannot live with 4 servers. I need to rebalance the data now among the 5 servers. So I would do something like 152 modulo 5, right? Which will give me 2. That means Now the data resides in server 2. 7 modulo 5, which again gives me 2, which means it's server 2. 81 modulo 5, which gives me 1, which means now the data for this user is in server 1. 18 modulo 5 is 3, which means now the data resides in server 3. So we have seen that for the first user, the data needs to move from S0 to S2. For the second user, it needs to move from S3 to S2. For the third user, it remains same. For the fourth user, it needs to move from S2 to S3. Okay, so you can say that almost a lot of data needs to be rebalanced. Like if I had the 4 TB of data and I want to now redistribute it to 5 different servers, 80 to 90% of my data needs to be rebalanced from one server to another server, and that copying that data and everything needs to be done. So it's very expensive operation, right? Now let's take a case when we decrease the number of servers. Let's say we have 3 servers now. Then how the mapping would change. 152 modulo 3, it gives me 2, which is like S2 server. Then 7 modulo 3 is like 1, which is like S1 server. 81 modulo 3 is 0, which is like S0 server. Then 18 modulo 3 is again 0, which is like S0 server. So if we remove the servers also, we see that a lot of rebalancing is done, or almost everything is rebalanced, right? So definitely this is not a feasible or a scalable solution, because servers will always keep on coming up, right? And like we might have to scale up or scale down as and when required. How we can make this better? So we can think about a ring. Ring is basically nothing but a virtual ring. Okay, and earlier what we were doing is we were only hashing the user and then determining which server it would go into. Now we'll take a ring and then assume that ring is like from 0 to 359. You can think of it like a 360-degree ring. And over here, we not only just hash the users, we also hash the server IP addresses, right? So let's say if we hash the server IP addresses and it comes out to be S0 is somewhere like 20. Then let's say we have S1 at 180. S2 at maybe 100 and S3 at 250. So, and then what we do, we just plot it, right? So here, somewhere here it would be S0, somewhere here it would be S2, then somewhere here it would be S1, and somewhere here it would be S3. So now we have allocated points for all the servers in our ring. So now what we'll do is we'll also hash the user, and instead of doing that modulo 4, we can do this modulo 360 and come up with the number. And then how do we determine which user's data will be stored in which server? So let's say that the hash value comes out to be somewhere here, which is like somewhere like 30. Okay, so what we'll do, we'll just move in the clockwise direction and see what is the first server we see. So over here, the first server that we see is S2. So that means we can say a users whose hash value is 30, the data would be stored in S2. So when we want to write it, we'll store it in server 2. When we want to read it, we'll store it in server. We'll read it from server 2. Okay, let's say there is some value here which is, let's say 270, and this is another user U3. So where will this U3 data be stored? I'll just start moving clockwise, and then see, okay, S0. So U3 users data would be stored in S0 server. So now what we have done is we have distributed all the user in a ring and we have distributed servers in a ring. Now how this is beneficial? Does this require rebalancing? Let's say we want to add a new server. Okay, when we add a new server, let's see what happens. So let's say this next server goes somewhere here, which is like server 4. Okay, we added a new server. So now we can see that, so any user which was earlier lying between S0 and S2 will keep on going to S2. There is no change, no rebalancing needs to be done. Anything between S2 and S1, no rebalancing required. Anything between S1 and S3, no rebalancing required. Anything between S3 and S0, rebalancing is required, because now from somewhere from S3 to S4 in this range, all the keys that were earlier going to server 0 will now start going to server 4. And from S4 to S0, there is no rebalancing that is required. So we see that only a very small segment of users who are lying in this range, that is S3 to S4, will start going to S4 instead of S0 now, right? Now let's take a case where we want to remove a server. Okay, so we have S0 here, we had S2 here, we had S1 here, we had S3 somewhere here. Now let's say if you want to remove S2, let's see what happens. Anything from S3 to S0, nothing changes because the first server is S0, right? Anything from S1 to S3, not changing because the first server is S3. Now things from S3 to S2, S0 to S2, whatever was there between S0 and S2 will start going to S1 now. So this rebalancing is required, but anything from S2 to S1, there is no rebalancing that is required, right? Because it would keep on going to S1. Okay, so definitely we have solved the problem of that there were a lot of rebalancing that was happening, and a lot of data needs to migrate from one server to the other. But if we see, there are two key issues. Over here, what happened? Only a small segment of traffic, which was earlier going to S0, now moves to S4 when we added a new server. That means the load on S2 still remains the same, load of S1 still remains the same, load on S3 still remains the same. So only whenever a new server comes up, it is only taking the partial load from one particular server, that is S0 here, right? But ideally, when you would want a new server to come up, you would want it to take the load from all the different existing servers equally, right? And when a server goes down, you would also expect to distribute the load equally. But here what is happening? S3 load is not increased, S0's load is not increased, but S1 server's load is doubled, because S0 to S1, earlier everything that was going to S2 is now going to S1, and S1 is still maintaining whatever it used to maintain, plus it also has to take a load of S2. So this doesn't uniformly does a rebalancing. It is doing minimum rebalancing, but it's not doing it uniformly. Okay, so now what we can do is since everything is a virtual ring, like virtual points, right? So instead of giving one point in this ring to a given server, we can give multiple points. Now let's say we have S0, I have given S0 to here, here. Let's say I've given just 5 points. S1 I can give here, I can give here, I can give here. Okay, S2 can come here, here. So now for a given server, I have given multiple points, and now there are very small ranges that are there. So S1 will be taking this range plus this range plus this range. Okay, now let's see what happens when S1 goes down, right? So let's say if S1 is going down, okay, what happens? So S2 will take a small traffic for this range. Okay, over here S1 is going down, so S0 is taking the load, extra load. Over here S0 is taking the load. So basically it's not just a single server that has taken the complete load, it's multiple servers that have taken the load. And when we add new servers, what happens? Let's say if I add a server here, S4, let's say S4, over here S4. So now this S4 has taken the load for server 0. Over here it's server 0, over here it's server 2, right? So we clearly see that whenever we add a new server or when we delete a new delete an existing server, the load is now not getting, like, we are not just pushing the load to a single server. Instead we are trying to do a better way and like a more uniform rebalancing, that we are doing when we start allocating more points, because now we are only having small ranges instead of big ranges between the two servers, right? And there are multiple ranges for which a server is responsible. Okay, so yeah, I think that's all that I had for consistent hashing, and thank you guys. Have a great day.